We looked over characteristics of a function. The only difference is we're going to talk about continuous functions. In the other example, I showed you, I think, 5 different ways to represent a function. Now, these ones they've graphed for us, okay? And we'll talk about, but there's actually equations that represent these and how to draw them. What we really want to know is A, is it a function, and B, what the domain and range is. Those are really the only 2 major ways we can represent continuous functions. I'm going to talk about the reason why. First of all, if I draw vertical lines, does this pass the vertical line test?
Yeah.
Yeah. So is the first one a function?
Yeah.
Yeah, the first one is a function. In fact, it's called a linear function. Okay. So yes, it's a function. Okay. Now, domain and range, and this domain and range is going to explain why we don't really represent continuous functions with mapping diagrams, or we can represent them with tables, but we're kind of cheating when we do. The reason for this, remember, domain deals with our x values and range our y. The reason for this is, first of all, what is the domain? What are the x values here? And remember, this goes on forever. What are the x values? Anyone name them? So, for instance, is there a point at 2? Yeah. Is there a point at 3? 4? How about 4.5? How about 4.25? 4.00001? So could I essentially find an infinite amount of points?
Yeah.
Yes. So we don't write them out as numbers because I would never be able to finish my domain. Instead, we use something, and it's called x is the element of all real numbers. So what we do is we write it like this. X looks kind of like a capital E and an R. Real numbers are essentially any number possible. Okay? And you can even think of it like x is every real number. That's going to represent a continuous domain, something that goes on forever and ever. And that's why we can't really represent these with mapping diagrams, because I don't want to write every possible number ever made. So we wouldn't represent it with like really a table or a coordinate or mapping diagrams. We essentially represent them with graphs or domain and range. So with that being said, what do you think the range? What are the y values of this function? It's the same thing. How would I write it then? That's right. Y, E, R. Okay? So that represents every possible x value and every possible y value. The linear function does. It represents every number possible. Okay, so let's move to the second example. Second example is what we usually look like, a quadratic. If I draw vertical lines, will it pass the test?
Yeah.
Who thinks no? Who thinks yes? It actually will. Well, it will pass this test, assuming I drew it properly. Okay? A quadratic is a function. Okay? And even though the slope might get very, very steep, technically it should only pass through once. Okay? So yes, this is a function. So I'm going to say yes here. Now, this is a little different, our domain and range. First of all, our domain. Let's write our domain out. Because we have arrows at the end, the idea is this parabola can go to the left and to the right forever. So what would the domain of this one be? If it can go left and right forever, how would we represent it? XER, that's right. It's every real number. Okay? Now, our range represents the y values. It's going to be a little different. For sure, our y values go up forever. But where is our stopping point? Because we're talking about y, we're only looking at the y value. So what's the lowest y value? -2. So it is continuous. Okay. So it does represent an infinite amount of points that way. So when we go to start it, we are going to say YER, but there's a restriction. Okay. And we draw a line here to represent the restriction. And we're going to say that y is every real number when y is greater than and equal to what value? -2. Okay? So that represents every possible number above and equal to -2. That's what that is saying. Okay? So with that same idea, we go to our third example. Vertical line test. Does it pass? Is it a function? No. This one is not a function. Does not pass the vertical line test. But I can still get a domain and range for it. My domain Are there any restrictions on my domain? That's a really funny looking bracket. There you go. What's the restriction on the domain, or what I tried to get it to? 3. That's right. And what is it? Is it greater or less than 3, all of our x values? Yeah, they're all going this way, right? So how do I write this? XER, that line such that x is just greater than 3? Yeah, it does touch it, so we have to say greater than and equal to. How about our y values, or our range? Will they go up and down forever? So what's our range? Y, ER. Okay? Finally, last example, vertical line test. Does it pass? Not even close. Not a function. The domain and range is a little tougher on this one. It looks like it has specific points. I'm just going to stop. Okay. So our x values exist at -4 and roughly +4. They exist at every number between those values. So we still start off the same way. We say domain is XER, so it's every real number, such that now we have restrictions. And what I'm going to do is I'm going to start with the smallest one, -4. Okay, and x is greater than or equal to -4, but less than or equal to the value of 4. Okay, so I have a number on each side of the x saying that it is larger than -4, but smaller than +4. So with that same idea, okay, the lowest y value looks like -1, and the highest one is, 7. What will our range be then? How will we write our range? YER? Is it 1 or? We have -1. What variable's here? Y. And what's it less than? That's right. Okay. So that's how we represent continuous functions in this math.